Welcome to the bridge for this week, a look back of where you've been and a look forward at where we are going. So this last week we covered lessons 3, 4, and 5 in chapter 7, and we were talking specifically about functions, how to add, subtract, multiply, divide, and combine with composite functions. We learned our big takeaways where that order matters. We need to check and make sure it's still like terms, even if our exponents are now fractions. We know that we can still use all of our same math rules and that composites combine both of the equations. And it matters which one goes, and the easiest way to put them together is to take your one function, and as you write your numbers, you're going to leave a space for that x and then put in the other terms that might be there. And then you put your inside function. We also learned that it's important for our composite functions that the first function that you do goes on the inside. This would be number 1. And the second function that you work is going to be on the outside. So we have number 1 and number 2 in the order of our composite functions. We tackled inverse equations. And we found out that inverse equations on a coordinate plane looks a lot different than what we think of on a number line. And instead, we are now looking at a line of reflection that is y equals x. So we're now reflecting across that 45-degree angle line. And when we fold it in half, we will have a mirror image across our line of reflection. We found that if we simply take an equation and we switch the x and y, it will give us the inverse equation. And we just have to solve for the new y. As we moved on to 7.5, we looked at actually graphing the equations and their inverses. We learned that the inverse of a squared equation is a square root. The inverse of a cubic equation is a cube root. And we saw that they looked a lot alike, that they are actually all exactly the same. It just depends on what the value around the x is. So our a values are going to be exactly the same. If I had an, let me redo that. If I had an x, h squared plus k. Our a values are the same for them. That's our slope that we can talk about from our vertex to our first point. Anytime we have an h and k, for either of them, it tells us how far that our vertex has moved off the origin. If we are looking at a cubic equation S-curve, that vertex point is the point where the curvature changes. So it's that little middle point. And so it tells us how much this point has maybe moved off the vertex according to the h and the k. And so knowing what we know about inverses, where we can switch because they're just swapped, our x and y are swapped, we were able to take maybe one equation and write the other one because we change our exponent. So here we changed our exponent from a 2, it went to a 1/2. That's the inverse of 2. So we went from 2 to a 1/2, or we might have gone from a 3 to a 1/3. That would be going from an exponent of 3 to a cube root. And we needed to simply switch our h and k values. And then we're going to take all of that information that we practiced this week, and next week, we're going to look at 7.6 and chapter 9. And how those tie together is in 7.6, we are now going to be actually finding our x. We're going to use all of the new tools that we have in our tool belt, maybe from finding inverses, maybe knowing how to graph, how to write our inverse graph and our inverse equation, use our operations and our order of operations, and use our wonderful PERMDAS, and we are going to actually find a solution for x. We will be able to graph and sketch our solution, we'll be able to decide if our graph ever does, in fact, cross the x-axis, and if so, where it does. And we will be able to mathematically and graphically show all of those different points. In chapter 9, we're going to see how, once again, direct relationships and inverse relationships work together. We know that a direct relationship is the y equals x when they are on opposite sides of the equal sign and they are both in the numerator. Then it has a direct relationship. When y goes up, x goes up. If we have inverse relationships, we have 1 on the top and 1 on the bottom, just like 2 equals 2 or 2 equals 1/2. These are our inverses. We now understand why our inverse is called the number or value a or x to the -1, because it's changing the side. It's giving the reciprocal. So we're going to take what we know about direct and inverse relationships and where we actually place them in an equation. And we're going to be able to simplify these fractions, because anytime we have an inverse equation, we end up with a fraction. And again, the whole point is to find x. So we're going to walk through all of our different steps along our map. We're going to use our scavenger hunt and figure out how can we solve polynomial fractions using everything that we know about our order of operations for equations. Now, if I have a larger equation, maybe x squared minus 4x plus 4 over x minus 2, can we simplify this to find an x? We'll go all the way back to chapter 5 of factoring. We will tie that in with everything else that we have. We will be able to look and see maybe if we have a negative exponent, and we'll be able to change sides in the fraction. We'll look and see if we have any square roots, and we'll be able to simplify them. And look at our entire fraction equations and now be able to simplify out larger terms. So that's where we were, and that is where we're headed.